Hello everyone. Our presentation topic is TSV packaging and its challenges on high CAGR semiconductor. TSV technology is to create vertical pathway to connect stacked chips or wafers. In the field of packaging, it replaced the edge welding to become a high-performance interconnect technique and plays a crucial role in 3D integrated circuits. Compound annual growth rate (CAGR) is the rate of return that would be required for an investment to grow from its beginning balance to its ending balance. That means the rate at which an investment would have grown if it had grown at the same rate every year, and the profit has were reinvested at the end of each year. The CAGR is not a true return rate, but rather a reputational figure. In the following presentation, we will show the evolution and the process flow of TSV technique. Finally, we discuss the challenges brought by TSV on high CAGR semiconductor devices. Human dependence on technology is unstoppable, and is always desiring for a new achievement. In search of excellent electronic devices have to be more compact in size, but higher in efficiency. In the past, it is difficult to compress the overall volume of the chips because of the essential presence of metal wire bonds and the solders for electrical conduction. However, TSV technique creates a new page for the packaging architecture. In the presence of TSV, the IC innovation steps into a new generation. The interconnect and device density is substantially higher, and the length of connection becomes shorter. It improves the functionality to volume ratio as well as the conduction efficiency. The history of the TSV. A TSV was invented in 1962, but is not originally designed for 3D IC. The first TSV 3D IC is fabricated in 1980, Japan. Hitachi filed a Japanese patent in 1963, followed by Fujitsu in 1984. Substantially, the term TSV was coined by True C Technologies researchers. They proposed a TSV method for a 3D wafer-level packaging solution in 2000. TSV used for commercial products in 2007 to 2008. In 2010, TSMC announced plans for 3D IC production with TSV technology. The TSV process can be divided into three types: via first, via middle, and via last, according to the steps of via formation. The via first process is etching the via and filling it with metal at the beginning of process. Its advantage is low cost, higher via density, and the disadvantage is copper will diffuse into the silicon substrate during the high temperature process. So most of via first process use higher resistance silicon oxide as the fill-in material. The other disadvantage is thermal stress issue. The via middle process is forming via after front-end process. Its advantage is copper will not diffuse into substrate because copper is not processed at a high temperature. The disadvantage of this process is also thermal stress issue because of back-end process. The via-less process is etching the via at the end of process. An advantage of this approach is that the thermal stress the thermal stress issue is lower than the other process, and the disadvantage is it has higher requirements for alignment and etching technology to avoid damage to components during etching. This is the process flow of TSV fabrication. The first step is etching the via. The challenge of this step is high aspect ratio and the controller profile. And the second step is deposit the oxide. This layer is to stop metal diffuse into substrate. And the third step is deposit the C layer. And the fourth step is deposit the metal. And this step challenge is void free and low stress. Then final step is CMP. This step is to polish out the extra metal. And the challenge of this step is endpoint control.
So, by the definition of CAGR, it is known of the rate of return that would be required for an investment to grow from its beginning balance to its ending balance. The compound annual growth rate isn't a true return rate, but rather a representational figure. It is essentially a number that describes the rate at which an investment would have grown if it had grown at the same rate every year, and the profits were invested at the end of each year. In reality, this sort of performance is unlikely. However, CAGR can be used to smooth returns so that they may be more easily understood compared to alternative investments. To calculate the CAGR of an investment, first of all, we need to divide the value of an investment at the end of the period by its value at the beginning of that period. 2. Raise the result to an exponent of 1 divided by the number of years. 3. Subtract 1 from the subsequent result. And now I'm gonna to introduce the use of CAGR, which the main purpose is to track the performance of business strategy and detect the weakness and strengths. CAGR can be used to track the performance of various business measures of one or multiple companies alongside one another. For example, over a 5-year period, Big Sales Store's market share CAGR was 1.82%, but its customer satisfaction CAGR over the same period was minus 0.58%. In this way, comparing the CAGRs of measures within a company reveals the strengths and the weaknesses. Comparing CAGRs of business activity across similar companies will help evaluate competitive weakness and strengths. For example, Big Sales customer satisfaction CAGR might not seem so low compared with Superfast Cable's customer satisfaction CAGR of minus 6.31% during the same period. Okay, so for the CAGR of the 3D TSV devices market, the 3D TSV devices market registered a CAGR of 6.2% over the forecast period from 2021 to 2026 due to the need of better performance in edge computing applications. Rising demand for miniaturization of electronic devices drives the growth of the 3D TSV market. These products may be achieved by hetero system integration, which may give more reliable advanced packaging. With extremely small MEMS sensors and 3D packaged electronics, one can place sensor virtually anywhere and could monitor equipment in harsh environments in real time to help increase reliability and uptime. Although there's a whole bunch of benefit through bought by TSV, there's still a main issue we need to overcome: the thermal issue. Thermal issue caused due to high level of incorporation is a challenging factor of the growth of the 3D TSV market. Since TSV provide the key connection in 3D IC integration, the difference of coefficient of thermal expansion between silicon and coppers is more than 10 ppm per K, which provide thermal threats with when a thermal load is applied. Due to the impact of COVID-19, the expectation of advanced packaging market in 2020 has decreased nearly 7% comparing to 2019. Undoubtedly, COVID-19 poses a challenge to the world, but it also has a positive impact of the semiconductor industry. It changed the way of life and work. For example, working at home and investing in automation have become a major trend, which is bounded to drive market demand for computing, microprocessing, and memory components. In this context, 2021 will be a year full of opportunity for the semiconductor industry. And that's all for today's presentation. Thanks for your attention.